The purpose of this video is to illustrate only one case of the law of sines. So I am assuming you know what the law of sines is and that you have used it before. This also is titled the ambiguous case because you're either going to have one, two, or no solution in this situation. It's just for this case when you're given two different sides and one angle, and that angle is not between the two sides. So make sure you have a calculator handy. Make sure your calculator is in degree mode. Before I show you a specific example, I'd like to first illustrate to you why the side-side angle case is ambiguous and why you could have no solution, two solutions, or one solution. So first of all, in the box here, this is the law of cosines. And most textbooks use alpha, beta, and gamma to represent the angles, and lowercase a, lowercase b, lowercase c to represent the length of the sides. Now, do not be confused because this is two sides and an angle. This also is two sides and an angle in between. So the side-side angle and the side angle side both include, or you're given in the original problem, two specific sides and an angle, but the location of that angle is crucial. If the angle is not between the two sides, like on the diagram here, you have side, side, angle, that is where you're going to have to check for either one, two, or no solution. If the angle that's given is in between the two sides, it's going to be very straightforward. There aren't any tricks. There will most likely be, well, not most likely, there will be only one solution to this. You don't have to worry. One way that I memorize or remind myself about the ambiguous case is notice that SSA spelled backwards is a bad word, and this ambiguous case is a pain in the SSA, literally. So the next, I'm going to show you three different examples. Each example will illustrate, the first one's going to show you why or when no solution will occur. So there are problems that are given where the information provided is totally bogus. You cannot make a triangle after using the numbers that are given. The second example that I'm going to show you is the information given, side A, can create two different triangles there. So it's like this swinging, arm that can be connected here and it can be connected there, creating two different triangles. And then the third example, the length of side A only creates one triangle. Notice that if I were to extend this blue line the same length as A, it's too long and it doesn't connect to the triangle as the second example does over here. Now what I'm going to demonstrate to you is I'm going to do the same exact problem three different ways, but all I'm going to do is I'm going to change the third side, or actually the second side given. This example I'm going to have A as 20. The second example, A will be 30, and the third example, A will be equal to 40. And you will see that each, depending upon the length of this A value, it's going to change if you have 0, 1, or 2 solutions. So first of all, I want you to notice the directions. It says solve the triangle, and then there's given 3 bits of information. An angle, a side, and a side here. So what I always do is, no matter what's given in the problem, is I always make a little diagram to remind myself if this is a side angle side or a side side angle situation. In the upper right hand corner, this is the model that you use. So this is important that you label the information given in the problem accordingly, that opposite of side A is alpha, opposite of side B is beta, and opposite of side C is gamma. So that's important. So if the given information here is A is 20, opposite of side A has to be alpha, okay, which is 42, so I label the angle there. And then side B is 35. So opposite of side B, which is my question mark here, is beta. All right? So I'm going to approach this problem, even though this video is about side angle, I'm going to approach this problem, and actually the next two examples, blindly, because in your homework, most likely you're going to have a side scenario, a side angle side scenario, an angle side scenario. So to me, it's always helpful to draw a little picture, labeling the information, just so that you have an idea to keep track of all the values. So as you can see here, is I use the law of sine with the given information, sine of alpha over side A here, and then this is sine of beta, which I don't know beta in this case, over side B. So I want you to notice that everything in this little setup here is using the given information. Okay? Now if you cross multiply, so let me erase this thing here. If you cross multiply after you set up the law of sines, all I'm going to do is multiply 20 times sine of beta is here, okay, and then 35 times sine of 42 is here, okay. Now, so once again, like I said in the introduction, I'm assuming you know what the law of sines is, that you know how to solve this. So I'm just going to go ahead and abridge this and take you down to the final answer. Now, to solve for angle B is I would just have to divide both sides by 20. Okay. Now all of this comes out to this decimal here. All right. Now if I want to solve for the angle, I just do sine inverse. On your calculator, you'll notice that there's a sine button, and right above that is a sine inverse button. You probably have to hit second or shift to get that. Now when you do sine inverse of that decimal, it's going to say error, domain, or no solution, something of that matter. And in this case, this is the first situation of the ambiguous case where your calculator will tell you if there's no triangle or not. Your calculator will say error, you cannot solve this. Your calculator, actually the range of sine cannot be bigger than 1. It's actually trapped between -1 and 1. So your calculator will tell you error, and see what's happening in the given information. If you look at the 20 here, if I slide that over here, that 20 side is not long enough to connect to the other side of the triangle. Okay? In all of these problems, the given information will not change. The 35 doesn't change, the 42 doesn't change, the 20 doesn't change. But as you can see, the 20 is not long enough to connect. So there is no triangle. Okay? Now the next example, I'm going to do the same exact thing, and I'm going to approach it blindly, and I'm going to label a triangle. It's going to seem redundant, but that is how I suggest you approach each of these problems. All right, you may want to take a second and look at the previous example. Notice the directions is exactly the same as the last example. The only thing that I changed was that I changed A from being 20, now it is 30. All right, now I've labeled the triangle here, and using the given information, I label the triangle. I notice that the information is side angle, and it's a pane in the SSA. So now I have to check if there's 0, 1, or 2 solutions. In the previous example, you saw that there is no triangle. This is a situation where there's more than one solution. Okay, so I set up the law of sines the same way I did in the previous example. I cross multiply to get this, divide both sides by 30 to get this decimal. I do sine inverse of both sides, it spits out this angle here. Okay, so notice my calculator does not say error, it actually gives me an answer. And once again, make sure your calculator is in degree mode, okay, because that's all this information, this is a degree bubble. So make sure your calculator is in degree mode. Now, the given information is that alpha is 42, beta is this. Well, the sum of the angles in a triangle is 180. So to find the third angle, which is gamma, I just subtract my given angle. That's the bell for school to get out. I just subtract my given angle 42 minus from 180, and then minus beta, which is the angle I just found. And so the third angle is about 87 degrees. Now, using this information, I can find the third side. So going back to the original directions here, whenever it says to solve a triangle, you're finding all the missing pieces. I'm given in the original problem 2 sides and an angle, so that means I have to find 2 angles, beta and gamma, and the third side, which is side C. All right, now here's the ambiguity here, and the reason why it's called the ambiguous case. You may find a formula in your textbook, but I'm actually going to give you a reason why there is a second solution. So what you're going to do is you're going to ask yourself, is there a second solution? Okay, so we just found one on the, I do a split screen here. So on the left here, this is one solution, and if there is a second solution, I always draw a line down my paper so I don't use the two values, so I don't mix them together. Otherwise, it just looks like a big blob on your paper and you start using values you shouldn't. So I suggest you just draw a line down your paper, and you're going to ask yourself, is there a second solution? Now, if there is a second solution, which I'm going to call beta sub 2 here, okay, which means that on the left, this is beta sub 1, is 51 degrees, beta sub 1 here. If there is a second solution, what I do is I take the given angle I just found on the left, which is beta, this is beta sub 1, or my first solution, and I simply subtract it from 180. So if there is a second solution for beta, it's going to be 128 degrees, 129 degrees about. Now, I don't know if that is a legit answer or not. So all I have to do is I have to check to see if this makes sense. So if I take beta, this solution here, 128.68, and I add the given angle that the angle that's in the original problem, and I add those two angles, it's equal to 170.68 degrees. Now, is there room for a third angle? And what I mean by that is that a triangle, all three angles have to add to get 180, right? Well, these two angles alone add to get 170.68. That is less than 180 degrees, which means, yes, there is room for a third angle. There's not a lot of room, but there is room for a third angle. So then what I do is I just proceed, is I take 180 degrees, which is the sum of all the angles in a triangle. I subtract my second beta solution, which I just found up here. Oh no, this 170 is alpha and beta combined together. So that means the second gamma solution is going to be a skinny old angle of 9.32 degrees. Now, based upon that angle measure, I can find a second C value. So this is where we have two different solutions. Now, look back in the upper left where A is 30. Okay. Now what that means is, since there are two solutions, that length of 30 can connect a triangle here, and it also can connect a triangle there. That's why there are two solutions. Okay, so I got 30 here, and 30 for that little stick there, and it creates two different triangles. The beta, beta of 128. Okay, let me make some room here. Now, I really want you to see this because it makes so much sense. This second solution of 128 is this obtuse angle in the triangle. Okay, that's 128 degrees. And my other solution, my first beta solution, is 51 degrees. That is the angle right in there. All right, so notice the given information in my problem did not change. 35 didn't change, 42 didn't change, and the 30 didn't change. But what changes is the beta has two different solutions. There are two different gamma angles, and there are two different C sides. Ambiguous case, this is where you have two solutions. The next example I do, I'm going to do the same exact process, except the A value up here in the upper left is going to be a 40. All right, now for the third example. Notice the directions given is the same as it always has been for the first two examples. Same exact information, except now A is 40. Now I'm approaching this blindly. I'm not assuming that this is a side-side angle. I use the given information. I create a picture. I see that it's a side-side angle. That's a pane in the SSA, so I tell myself there's either 0, 1, or 2 solutions. I set up my law of sines. I cross multiply to get this. I divide both sides by 40 to get this. I do sine inverse, and I get this. All right, so that means that there's at least one solution, and I have to ask myself the same question as I did before. Is there a second solution? Now, just finishing off the first solution, though. Okay, let's do a split screen here. Another bell. Sorry for the interruption. Da, da, da. But I don't really want to refilm this, so I'm going to keep going. Now, finishing off my first solution here, I just found beta. Now, with that beta is I take my beta here, I subtract that from 180, and I take my given alpha here. That means that gamma has to be 102.17 degrees. And with that, I can also find the C value, okay? And I can use the law of sines or even the law of cosines to find out the third side. Now I have to rule out if there is a second solution. Now I'm going to ask myself the same exact question that I did in the previous example. Is there a second solution? Now what I do is I take the given angle I just found, 35 degrees on the left, and I subtract that from 180. Because if there is a second solution, it's going to be the supplement of that. Supplement angles are angles that add to get 180. So I subtract that from 180 and I get 144 degrees. Now that's just one angle. That is my hypothetical beta sub 2, which is my second solution. Okay? Now my given angle of 42 doesn't change. That doesn't change throughout the problem. Now when I take my answer of my possible second answer of 144 degrees and I add that to 42, I get 186 degrees. Now a triangle, all three angles have to add to get 180. So far I have two angles adding up to something greater than 180. That is a contradiction. So is there room for a third angle? The answer is no. So there is no beta sub 2. There's only one solution, and it's over here on the left. Okay? In the previous example, the answer was yes, there was room for a third angle. So then I had to find all that solution. I had to find the other solutions. I had to find the other gamma value and so forth. But in this case, it's a no, so that means there's only one solution. And if I take the given side of 40 in the upper left, I'm going to circle it now, and I bring that over here on my diagram. Notice the 40 is long enough where it only creates one triangle. Beta sub 1 is 35.883 degrees. This picture is not to scale, but it is just a picture telling you to illustrate the truth. So I suggest that if any part of this video, it's very long, about 20 minutes long, that you go back and watch things and pause it as you do your homework assignments. And I wish you the best.